In this lesson, our goal is going to be learning the basics of how to evaluate algebraic expressions. Do you have your notepad and your pen ready? If not, get them and then we'll get started. Okay, so here's our course outline, and this is Intro to Algebraic Expressions Part 2. And the learning goals would be knowing how to find the value of the algebraic formula and explain the actual meaning of the value, and using the algebraic expression evaluation to infer the law of algebraic expressions. So here's a quick little introduction. According to newspaper records, a doctor studied the formula for predicting the height of a child from the height of the parents. The height of a son is the half of the height of the parents and multiplied by 1.08. The height of the daughter is 0.923 times the height of the father plus the height of the mother, then divided by 2. 1. It is known that the height of the father is 1 meter and the height of the mother is b meter. Use algebraic expressions to express the height of the son and daughter. Use an algebraic expression to express the height of the son and daughter. First, quickly jot this scenario down. Okay? And then I'll be giving you the information over here. Pause the video and try to do it. Kind of like the problems we did in the last lesson, this problem was giving you a list of facts or clues about which operations to use, and then giving you a more specific scenario, and then it was asking for you to make an algebraic expression that expresses that scenario. Well, we know that the height of father is 1 meter and height of mother is b meter. And then over here again, it said that the height of the son is half of the height of the parents multiplied by 1.08. And then the height of the daughter is 0.923 times the height of the father plus the height of the mother divided by 2. Okay? Then if we come over here, it says that the height of the father is 1 meter, mother is b meter. So I'll write mother equals b meters and father equals 1 meter. So the height of the son, here's sun, is going to be equal to half of the height of the parents and multiplied by 1.08. So that would be b plus 1 because it's going to be half both of those divided by 2 and then multiplied by 1.08. And then we have to simplify this. And this is all we have. This is all we need. Then the daughter is 0.923 times the height of the father plus the height of the mother, then divided by 2. So the height of the daughter would be equal to 0.2923, because over here it's 1, plus the height of the mother, plus b divided by 2. These are the algebraic formulas, and if you want to, you should have simplified them. Okay, then it says that the height of a 5th grade girl, Jessica's father, is 1.75 meters, and her mother's height is 1.62 meters. 6th grade boy, Michael's father's height is 1.7 meters, and his mother's height is 1.62. Try to predict who is taller, Jessica or Michael, in adulthood. Okay, so I'm not going to go over it anymore, but I would highly recommend you just practicing this because it's going to give you some extra practice. And over here, and you can use the information given on the other side, and then all you have to do is use the same procedure. Okay, so here is the first section of our class, the valuation of algebraic expressions. So this is a numerical conversion machine, and over here it's entering x and then minus a 3. There's the result. Over here it's entering x minus 3 times 6, result. If it enters a 6 and then it multiplies a x, and then it multiplies a 6, that would be 6x. And the 6x minus 3, that would be 6x minus 3. Then over here it's x minus 3 first, so that's going to be x minus 3. And this whole thing multiplied by 6. So you might have seen how we got different results because of the order of operations. One, we multiplied a 6 first, and then the other one we subtracted a 3 first. And what happened was that we multiplied a 6 to not just to x now, but to this whole difference of x and 3. So if the entering number was -2, and all of these values, fill in the blanks of what's going to be the result of machine 1 and machine 2. Alright, all we really had to do was plug these values in the place of x in each of these machines. So the first one was -15. And remember, check your answers. -6, -3, -1.44, -1, 12, and 24. Result of machine 2 was -30, -21, -18, -16.44, -16, -3, and finally 9. These are the results. So really all we had to do was plug these in and replace them and replace x with these values, and then we'll get the result of machine 1. And all really we had to do was calculate, and then if we calculate correctly, we got the right answer. So let's discuss. Fill in the table below and observe the changes in the values of the following two algebraic expressions. Okay, so over here we have 11. And look, these are basically just the same exact thing as machines we saw earlier on, except that it was in this table form. So this is going to be 11, 16, 21, 26, 31, 36, 41, and 46. This is the pattern, 5n plus 6, and over here are the n values. Take a moment to kind of pause the video and look at the pattern that was displayed over here. Alright, and the second machine is n squared. These are the n values, so that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. Also, a good thing to keep in mind is when we're doing these squares or cubes, it's good to you might want to put down the first few squares of numbers and then the first few cubes of numbers, maybe somewhere in your notebook where you can come back to, because if you go through them frequently, it's going to help you get quicker with them, and it's going to help you get quicker with figuring out patterns later on. Okay, because when we're looking at patterns, your brain needs to function very quickly if you want to quickly and correctly identify a pattern in a problem. So you have to get really quick with your basic calculation methods. 1. As the value of n gradually increases, how does the value of two algebraic expressions change? How does it change? How does it change? What makes it change like that? Think about it. What makes these values the values they are? And what relationship do they have from the two values before them and after them? Well, it gradually increases. And 2. Estimate which algebraic expression would exceed 100 first. Which algebraic expression would exceed 100 first? Answer would be n squared exceeds 100 first. Because you see, over here, it's going to take a while to get there. And look, this is n squared. And then if you keep going on, it's just 2 more values until you can get 110 squared, which would be 100. It's only 2 more values. And this is, as you can see, it's not as quick as the n squared either. So as the values get bigger, they're going to be multiplying themselves 2 times, so it would be bigger along the way. Let's do a problem. When x equals 0 and y equals -1, find the value of negative 5x squared y plus 4 squared for x minus y. Remember, over here, I already told you that x equals something and y equals something. All you have to do is plug it in and then calculate the value of negative 5x squared y plus 4x minus y. Did you plug it in or calculate it? So over here, this is already its simplest form. And we're going to get to something like this later on in a future lesson. But all you really had to do was plug x in. So then that would be the letter x in the algebraic formula can be only replaced by 0, and y can only be replaced by -1. It cannot be misplaced. And over here, you see that when you plug 0 in, over here, 0 multiplied by something, the product is always going to be 0 itself. And so is the same over here. So that would become 0 plus 0 minus y. But y is equal to -1. So that would be, so minus y would be equal to minus -1. But remember how back in chapter 2 you learned how to deal in some calculation methods with negative numbers? Well, over here, subtracting a negative number is equal to adding that negative number's opposite number. So then that would be equal to add 1 or just 1. So all you had to do was plug them in and then calculate the value of it. So the solution is substitute in x equals 0 and y equals -1, and you can get the original formula, which is equal to -5 times 0 squared times -1 plus 4 times 0 minus -1, which is equal to 1. Conclusion. The value of an algebraic formula is determined by the value of the variable it contains and changes with the value of the variable. When the variable takes a different value, the value of the algebraic expression may stay the same or it might change. Okay, example 2. Knowing that a squared minus a minus 4 is equal to 0, find the value of 4a squared minus 2 times a squared minus a plus 3 minus 1/2 of a squared minus a minus 4 minus 4a. So let me give you a little hint here. It already told you that a squared minus a minus 4 is equal to 0. So all you have to do here is look. All you have to do here is try to make some of this into what you already know. You might have to find it, or you might have to use a calculation operation law that you learned earlier on in primary school, and try to make one, or even easier, find one of these. Go ahead. Did you get an answer? It wasn't that hard in the end, was it? So how it did was you first could see that this was a squared minus a minus 4. This we already know is 0. Okay? We already know that's 0. So it would be equal to 4a squared minus, let's just first multiply this in using distributive property. That would be a 2a squared plus 2a. Remember, this is actually a negative 2 here. So we have to multiply them in as a whole. Minus 6. Negative 2 times 3 is negative 6. And then we're going to minus 1/2 times 0. Well, 1/2 times 0, any number times 0, is going to be equal to 0 itself. So this basically cancels out, and then because it's 0, and then we minus a 0, and then minus 4a. Okay, and then we're going to evaluate this and simplify it. Well, how can I simplify it, you may ask? Well, let's look. So the first term, so one of these values that are connected by the addition and subtraction, is called a term. A term of this expression. So that's a term. The first term we can see is 4a squared. Well, if we have, and then we can think of a squared as, say, an apple. If we have 4 apples and then we minus another 2 of the same kind of apple, we're going to have 2 apples, which would be 2a squared. Remember, you can only do this only if the variable part is the same. Okay, only if the variable part is going to be the same. We're going to be digging deeper into this in a future lesson, but it's good to have a sense of it right now. Well, a squared and this a squared is equal, so we can combine these. And then it would be 4a squared minus 2a squared equals 2a squared. And then we add a 2a minus 6 minus 0 minus 4a. Well, we can see here that again, the same variable part appeared. This is 2a and then negative 4a. Since we see that they have the exactly same variable part, a, we can combine them and that would be 2a minus 4a. But we see that this is a larger value than 2a and this is being subtracted from it. That would just be negative 2a. And then we have negative 6 minus 0, that would just be negative 6. Now here's the tricky part. It says over here that 2a squared plus negative 2a minus 6. We don't see this yet. How can we do that? 2a squared plus negative 2a minus 6 is equal to the same thing as minus 2a minus 6. And then let's just not look at the 6 right now. Just look at this. Can we reuse the distributive property? Remember, when we're using the distributive property, it doesn't just have to be from left to right. It doesn't just have to be a times the sum of b plus c is equal to ab plus ac. It could be the other way around. It could be ab plus ac is equal to a times the sum of b plus c. You see how I did that little switch up there of the order that we did it? But since they're all equal, the order that we do it doesn't matter. We can reverse the distributive property. So what can we reverse here? What can we reverse? Well, you see, there's a 2, of course, there's a 2. So we could be 2 times, a squared minus a. Now you're asking, why did I do this? Why would I need a squared minus a? Look, over here, it says that a squared minus a minus 4 is equal to 0. Sure, I don't have a minus 4 over here to make it equal to 0, but it doesn't have to be. If we already know this, then a squared minus a would be equal to 4. If we add a 4 on both sides, it would make the equation true. It would make a squared minus a equals 4. So that means over here, we have a 4. Using what we know that we figured out over on this corner of the screen, we can use it and move it back into the expression, which would be, this part will become 2 times 4 minus 6. There. Now we calculate which would be 8 minus 6, which would be equal to 2. Just pause the video, and you might want to jot a few notes down in your notebook when we're solving these problems again. You might want to write a tip for yourself or a note that when we're doing these problems, you don't just need to have x equals 0 or y equals negative 1. You could have 0 equals a whole algebraic expression, and you might at first not even see where that expression is in the larger problem, but then all you have to do is kind of play around with it and then maybe use some distributive property or maybe addition properties or any type of property that you've learned, or maybe reverse it up a little bit, and then you would transform and morph it into the shape you want, which would give you many spaces to see, well, if that's 0, the whole thing is 0, or that's 4, okay, 2 times 4, 8. You can morph that problem into into the exact same problem, except that it's easier to solve, okay? And also, remember, as I did over here, I transformed a squared minus a minus 4 equals to 0. From that into a squared minus a equals 4. If I needed it, I also could have said, say, a squared minus 4 equals a squared. Equals a. This is a little switch up that you can kind of do or use with these clues here. You don't just have to follow the clue. You can morph the clue up a little so that it could be a bit more helpful. So take a look at the solution again. When you're ready, you hit unpause the video, and I would erase the ink on the slide. Are you ready? Okay. So let's take a look at this computer solution. According to the current knowledge levels, ordinary students cannot directly calculate the specific value of A. At this time, we have to consider a special evaluation method. According to what is known, a squared minus a equals 4. So after simplification, is the overall substitution to solve. So we haven't learned, and we don't need, and we cannot know the exact value of A. We don't need to. But we don't just have to know the value of A to solve. Why not use the value of a whole algebraic expression? Wouldn't that be better instead of just knowing the value of A? We know the value of a whole algebraic expression. So yes, like just what we just did, it told us the solution was also, it said, well, if I know this, then A squared minus A must be equal to 4. So after the simplification, we used the overall substitution to solve. We substituted the values in, and then we could just calculate. So because A squared minus A minus 4 equals 0, so A squared minus A is equal to 4. So 4A squared, so this is the whole solution here. And then the equation would be equal to 2. Now let's do some practice exercises. When A equals 2, B equals 1, and C equals 3, the value of the algebraic expression C minus the difference of C and A times the difference of C and B is equal to A1, B2, C3, and D4. Pause the video and shoot the letter. Once we replace all of these variables with their value, we can see that the final answer is A. It equals 1. It's also extremely important to remember to use order of operations in problems like this. 2. If 2A plus 3B is equal to 5, then 4A plus 6B minus 7 is equal to blank. When we're doing this problem like this second one, we first have to see what is the relationship between these two algebraic expressions. Well, we see that 4A plus 6B is exactly 2 times 2A plus 3B if we reverse the distributive property. Well, it said that this is equal to 5, and over here we have 2A plus 3B, so that would be equal to 2 times 5, which is 10. So we know that this part is 10, but we always have to remember to minus that 7. So 10 minus 7, that would be 3. Again, we always have to kind of find the relationship between two algebraic expressions to help us do these problems. Because we don't just have to know the exact value of A and B, we just need to find the relationship. Okay, now 3. Knowing that A plus B is equal to 5 and AB equals 6, then AB minus the sum of A and B is equal to blank. And then the answer would be 1. And the last problem. As shown in the figure is a numerical conversion machine, and the x going through the machine is -5. What would be the output of, it already said that we started with the number -5. And then we added a -2, which would be -2. And then from that, we multiplied a -7. So we simplify, and then it becomes 49. Remember, negative times negative is going to be positive. And the answer is 49. So did you get all of these correct? If you did, let's move on. 5. When x equals -3 and y equals 2, find the value of the following algebraic expressions. When x equals -3 and y equals 2, the first one, -3 squared minus 2 squared, which would be 9 squared minus 4 squared, which would be 5, and 2. It would become the difference between -3 and 2 squared, which would be -5 squared, and that would be 25. 6. Knowing that a equals -1/2 and b equals 2, find the value of a squared b minus 5ab squared. So after you replace all of these variables with their true values, you would get the final answer 23/2. And that's the answer. All you have to do is place the values in, and then you would get the answer as long as you calculate it correctly. Also, a tip to have when you're doing it is if it is a larger algebraic expression, you put it in, it's usually good to keep things look easier when you add parentheses. It's going to make it's easier to work with it. It's easier to work with it and then calculate it, and it's clearer. 6. A certain supermarket offers preferential treatment to customers during the Spring Festival. The regulations are as follows. So you might want to jot down quickly this table, and I'm not going to read out loud. So here's our first problem. If a customer makes a one-time purchase of X dollars in the market, when X is less than $500 but more than 200, he should pay blank dollars, and when X is greater or equal to $500, he should pay blank dollars. Express with algebraic expressions. Pause the video and try to see if you can use algebraic expressions to fill in the blanks. Okay, so this has lots of keywords in there that can bring us straight to our answers. For example, so over here it has that when X is less than $500 but more than 200. So X is less than 500 but more than 200. If the scenario was like that, then that would come directly into this scenario. Less than $500, more than $200. His purchase would be able to get a 10% discount. So X is going to be the original price, and then you have a 10% discount on X. Well, if you have a 10% discount on X, how much would you actually pay? If you already have a 10% discount, so minus 10% from the original X, then you get 90% of X. 10% X from X is equal to the leftovers, 90% X. So that would be also equal to 0.9x dollars. So then here is another one, and we use the same approach. And when X is greater or equal to $500, so when X is greater to or equal to $500, so when X is greater or equal to $500, that is exactly this scenario over here. $500 or more. Remember, more means the exact same thing as equal. So $500 or more. Well, it says that a 10% discount is given for the first 500 portion, and then 20% discount over the rest. That would be 0.8x plus 50. because what this means is we first have a 10% discount on the first $500, and then we get a 20% discount over the rest, so that would be actually minus 20%, and that would be 0.8x dollars. So 2. Read all these problems and then solve it by yourself in your notebook. So Miss Campbell made a one-time purchase of $600. She actually paid blank dollars. So we first have here that X is $600. X is $600. So now we have to look where X or 600 falls in these scenarios. Well, 600 is more than $500, so that would fall into this last scenario. Basically, that would mean the first $500 that comes in the whole amount, $600, is going to have a 10% discount. And the rest, which is going to be the $100, will get a 20% discount. 600 is equal to 500 plus 100. So this first 500 here will get a 10% discount. And this 100 here left over will get a 20% discount. And then that would leave us with 100% discount of 500. That's going to be 90% of 500. So that's $450 plus 20% discount for $180. So she would actually pay $530. Miss Campbell spent $170 for the first purchase and $387 for the second purchase. If Miss Campbell replaces these two purchases with one purchase, she can save blank dollars. So let's just first figure out the first option, spending them in different purchases. Okay, so we first have $170, and we want to see what scenario that falls in. Well, that is going to be, look, that's less than $200. This is less than $200. So that means it's going to be no discount. It's still $170. Now we look at $387. Well, that's in between $200 and $500. So that would be given a 10% discount. So that would be 0.9 times 387, which would be equal to 170 plus 348.3. If we add them together, that will give us 518.3. So our first option, option 1, would give us $518.3. So that's option 1. Now we have to find out what would be spent, how much would be spent for the second option. So spending them all together. The second option is when we spend these amounts together. Well, we first add these, so that's going to be 170 plus 387. 170 plus 387, that's going to give us 557. That's 557. Well, 557 is greater or equal to 500. That means the first 500 of 557 would be giving a 10% discount, while the rest of the cost left was going to be given a 20% discount. Let's go ahead. The first 500, that's the first 500, 557, is going to be given a 10% discount. So that would be 90% of 500, and then 90%, so let me write this down, 0.9 times 500 plus 0.8 times 57. There's a 20% discount on the amount left, which is $57. And then we calculate, which would give us 450 plus $45.6. We add them. That's $495.6. So option 2, $495.6. Now the real problem is not asking which option would be more efficient. It's asking how much money she can save if she used option 2 over option 1. We subtract this from this. 518.3 minus 495.6. And then it gave us $24.7. She can save $24.7. So now let's have a class summary. In this lesson, we learned the evaluation of algebraic expressions. And then in that full lesson, we had many lessons. So the first one was numerical number machines, direct substitution evaluation, and global substitution evaluation. So these are all the skills we've learned. First skill, knowing how to find the value of the algebraic formula, explain the actual meaning of the value. Second skill, using algebraic expressions to infer the law of algebraic expressions. So like the end of any lesson that you watch, I want you to take out your pen and notebook or pencil, and I would like you to jot down any important information that you might have on this lesson. If there are any key points that you would like to write down in case you might need it for a later on problem, you might need to jot that down too. Remember, this is your responsibility and you're responsible of what you put down. Anyways, right now if you have any big problems or questions that you didn't get during the video, jot that down as well and then go back and re-watch that part. If it is still unanswered, write us in the comments down below. A new video, lesson 4 of Unit 3 would be coming up soon, and I hope you are on the lookout for it. And to do that, make sure you hit the red subscribe button down below and hit the notification bell also. That way you'll get notified when we upload a new video and catch up with your lessons. Now goodbye, stay inquisitive, and I'll see you for lesson